Dear students, once again, very warm welcome to your own educational classes. Last week, we discussed about the salts and how they are formed. Now, we'll discuss about the properties of salts. Okay, so first properties of salt is if you see efflorescence. Okay, what is mean? Certain hydrated salts, when left exposed to atmosphere, lost their water of crystallization and crumble into powder. Such salts are called efflorescent salts and the property is called efflorescence. Okay, examples if you see, okay, carbonate, sodium sulfate, okay, magnesium sulfate hydrated. So uh, you can see, okay, water molecules are attached in them. Okay, water of crystallization. Okay, when the water is attached to these salts, this is known as water of crystallization. Okay, but when they exposed to atmosphere, okay, they lose their water molecule, you can say, or water of crystallization. Okay, crystallization means the water is attached in this compound. Okay, in Na2CO3, 10 molecules of water is attached. Okay, so they will be removed when we expose them, or they lost their water of crystallization when we expose them in atmosphere. So this property is known as efflorescence. Okay, and these salts are called efflorescents. Next is deliquescence. So certain water soluble salts, when left exposed to atmosphere, absorb moisture, okay, and get converted into their saturated solution. Such salts are called deliquescent salts and this property is called deliquescence. So opposite to efflorescence, this is just opposite to efflorescence. Okay, so example are ferric chloride, magnesium chloride, etc. Okay, so when we left exposed them to atmosphere, they absorb the moisture means water. Okay, so and they converted into their saturated solutions. Next property of salts is hygroscopy. So what is hygroscopy? Certain substances, when left exposed to atmosphere, absorb moisture and become wet. Such substances are called hygroscopic substances and the property is called hygroscopy. So hygroscopic substances are called as drying agents. Okay, so these are also known as drying agents. And they just become wet, okay, when we expose them in the atmosphere. So these property is known as hygroscopy and these also known as drying agents. Example are anhydrous calcium chloride, calcium oxide, okay, CO concentrated sulfuric acid H2SO4. Okay, so it is mainly anhydrous agent which is used in many chemical reactions. Sometimes question also asked. Okay, sulfuric acid is the best drying agent. Next property is hydrolysis. It is a phenomenon due to which salt of strong acid and weak base, or weak acid and strong base, on dissolving in water reacts with it to form parent acid and alkali, thereby rendering the solution either acidic or alkaline in nature. Okay, so in this you can see example ammonium chloride, when it is a salt of strong acid and weak base, as you know. Okay, ammonium chloride NH4Cl. So in this, HCl is a strong acid and ammonium hydroxide is weak base. So when they dissolve in water, when we dissolve this ammonium chloride water, it first feebly ionized and highly converted into ammonium hydroxide and HCl. So means it dissociates into their parent. Okay, by the which they formed. Okay, so you can understand them. So deleting the spectator ions NH4 plus H2O NH4OH plus H ion is here. The presence of hydrogen ion render the solution acidic. In general, a salt solution of a strong acid and a weak base is acidic in nature. So whenever a strong acid and a weak base combine, so their solution will be acidic. Other examples are ferric chloride, copper sulfate, ammonium nitrate and aluminum chloride. Next is sodium acetate. Next example is sodium acetate. So you can understand carefully. Okay, two examples are given here. It is a salt of strong base, NaOH, and weak acid, CS3COH. Okay, so when dissolved in water, it dissociates into their parent, okay, CS3COH and NaOH. So this reaction will be take place in the water, CS3CONa, okay, H2O, CS3COH plus Na plus OH minus. It means they dissociate into their ions. So if we take deleting the spectator ions CS3CO plus H2O, the reaction will become CS3COH plus OH minus. So the presence of hydroxyl ion renders the solution alkaline. In general, a salt solution of weak acid and strong base is alkaline in nature, and examples are potassium acetate, sodium sulfide, and sodium sulfide. Simple examples are there. Okay, whenever strong acid and weak base are combined, they form a strong acid solution. But when a weak acid and a strong base will be combined, the solution will be alkaline. Sodium chloride, next example, it is a salt of strong acid and strong base. In general, the salt of a strong acid and a strong base do not hydrolyze and the solution formed are neutral. So this is the example of when both the acids are strong, so they neutralize each other. Okay, so other examples are KCl, KNO3, NaNO3, etc. Okay, potassium chloride, potassium nitrate, and sodium nitrate. Fourth one, ammonium acetate. It is a sort of weak acid and a weak base. Okay, so the salt of a strong acid and a strong base do not hydrolyze, and this solution is also neutral. Okay, so next thing is water of crystallization. Okay, whatever we read in last, so definition also given here. The definite number of water molecules which enters into loose chemical combination with the salt when it crystallizes out of its saturated solution. Okay, so this is the definite number of water molecules. When you see the example of Na2CO3 dot 10H2O, it means every time, okay, only 10 molecules of water will be react with it. Okay, so hydrated salts with water of crystallization on heating lose their water of crystallization, that is loss of their crystalline shape, and the color fades. For example, if hydrated copper sulfate is heated, its color changes from blue to white and crystallization shape become amorphous. Okay, so simple example is here. When we heat it, okay, it is blue crystalline copper sulfate solution, copper sulfate. Okay, hydrated salt solid. Okay, so when we heat it, it dissociates. Okay, and it loses its water of crystallization and white amorphous. It will become white amorphous structure. Hydrated salts on heating become anhydride. Whenever hydrated salt heated, they become anhydrous. The substances that removes water molecules from a compound or other substances called dehydrating agent. I'm just tell you before that H2SO4 is a very good dehydrating agent or drying agent. Zinc and aluminium displace hydrogen from the acids as well as alkalis. These are the example of you have to keep in your mind. Zinc and aluminium displace hydrogen from the acids as well as alkaline. Therefore, they are amphoteric in nature. Sometimes question also asked in the exam, Z and zinc is amphoteric in nature or not. Okay, true or false. So these both are amphoteric in nature because they displace hydrogen from the acids as well as from the bases or alkalis. So if you see the reactions here, Zn plus H2SO4 diluted ZnSO4. Okay, these reaction take place and HCl. So you can see they displace hydrogen from both of them. Zinc powder also same thing do with when it dissolve with NaOH, combined with NaOH, and these are the reaction of aluminium which show its amphoteric nature because it displaces the hydrogen. The oxide of zinc and aluminium react with acids as well as alkalis to form salt and water as they only produces products. Therefore, they are amphoteric in nature. So their oxides also amphoteric in nature. Okay, so you can see whenever they react with ZNO plus H2SO4, okay, and whenever they react with acid or alkalis, they form salt and water. So you can see here, if one example, if you see only, okay, here one salt zinc sulfate and water is formed. Okay, other all example are same as, okay, and in which aluminum oxide example also given. So see it carefully. Reactions may be asked in exams. The hydroxide of zinc, aluminum and lead react with acids as well as alkalis to form salt and water as the only products. Therefore, they are amphoteric in nature. So they are hydroxide also amphoteric in nature because they form salt and water when they react with acids and bases. So these are the simple examples of zinc hydroxide and aluminum hydroxide. When they react with dilute H2SO4, they form their respective salts, ZnSO4, Al2SO4 whole tries, okay, and water molecules are also formed. And another example of lead also given here. Lead is also an amphoteric in nature, and lead hydroxide is amphoteric in nature. Zinc and aluminum example you already see. Okay, these reactions for the bases. Now solubility table of salts. Okay, if you see the solubility table, all salt of sodium, potassium and ammonium are soluble in water. All nitrates and nitrites are soluble in water. All sulfates are soluble in water. CSO4, PbSO4, BSO4, barium sulfate, lead sulfate, okay, calcium sulfate. All chlorides, okay, are soluble in water. But PbSCl2, one example you have to see, PbCl2 is only dissolved in hot water. All sulfides are insoluble in water. These things you have to understand and remember that what are soluble and what are insoluble. So sulfides of these salts are always insoluble in water, and sulfide are also insoluble. Carbonates also insoluble in water. Now one thing you have to understand, the equation for the acid rain. The oxides of sulfur released from oil refineries and the oxides of nitrogen released by automobiles exhaust produce acid rain. Sulfur dioxide combines with oxygen and water to form sulfuric acid. Okay, sulfur dioxide combines with oxygen and water to form sulfuric acid. Nitrogen dioxide form nitric acid. Okay, so you know that acid rain is mainly caused by these two pollutants SO2 and NO2. Okay, so these reactions are also given here. So you can see sulfur dioxide make sulfuric acid and nitrogen dioxide making nitric acid. Okay, so whenever rain become in that area, it in the form of acid, that's why it is known as acid rain. And mainly these are released from sulfur released from oil refineries and nitrogen released from automobile exhaust, okay, which is major cause of acid rain. So I hope you all understand the concepts of acid, bases and salts in this chapter. Okay, we already understand about the acids, bases, their formation, properties, reactions with different acids and bases, metals, non-metals, and properties of salts, their reactions we will understand. So further, next in next class we will move to the analytical chemistry.